This is Lab 2, Lines of Charge. This lab is about estimating the amount of charge necessary to float one piece of tape above the other. Instead of treating the charge tapes as point charges, as we did in Lab 1, the tapes are modeled as a line of point charges. The fundamental principles used in this lab include charge, electric field, electric force, and gravitational force. The resulting charge on one piece of tape from this lab was found to be 1.025 times 10 to the negative 8 coulombs. In this video, we will go over the measurements, calculations, and computational model used to obtain this result. The measurements and calculations for this lab were mostly repeated from Lab 1. The length of tape B was found to be 0.214 meters. The mass of tape B was found to be 0.000214 kilograms, and the distance between the two tapes was 0.0349 meters. The magnitude of the gravitational force and electric force on tape B was found to be 2.099 times 10 to the negative third newtons. A computational model was made, which shows two charge tapes exerting an electric force on each other, and is used to estimate the amount of charge on each tape necessary to float one above the other. The tapes in this lab are not treated as a point charge. Each tape is simulated as a line of point charges, where the charges are distributed evenly across the length of the tape. It was assumed that each U-tape has about the same amount of charge, evenly distributed along the length of the tape. In the computational model, the yellow arrow represents the gravitational force vector, the white arrow represents the electric force vector, and the green arrows represent the electric field on the top tape by the bottom tape. Take note that the gravitational force vector and the electric force vector are equal and opposite. Tape A and tape B in the model are created using a for loop in the code, which is dependent on the input n, the number of uniform point charges in the line. In this model, n was set equal to 10. The charge of the tapes was determined by a guess and check method from the computational model, and was determined by setting the magnitudes of the electric force and gravitational force equal. The magnitude of the charge on one piece of tape, as calculated by the computational model, is 1.025 times 10 to the negative 8 coulombs. For comparison from Lab 1, the magnitude of the charge on one piece of tape was found to be 1.686 times 10 to the negative 8 coulombs. The charge obtained from Lab 1 differs from the charge obtained from Lab 2 because Lab 1 modeled the tapes as point charges, while Lab 2 modeled the tapes as lines of charge. The charge calculated from Lab 2 is more likely to be closer to the real value because it allows for an increasing number of charges on the tape. This is more realistic than the point charge model because the size of the tapes are not small compared to the distance between them.